All right, good morning, everybody. Welcome to week 6 of CNET58. This morning, we're going to talk about some of the storage features in ESXi, and we'll also look at some of the settings that we incorporated in last week's lab. We'll go over those a little more formally in the lecture portion of today as well. And then there will be a shorter, the lab is on the shorter side today, and it's going to be providing file share services using our Linux server. So last week we used our Windows server and our Windows 10 client to test everything. So this week we're going to use our CentOS server for our SMB share, and then our Windows 10 client or our Windows 10 host machine to test connectivity in that regard. All right, I'm going to share my screen real quick just so we kind of get a lay of the land of what's going on today. So let me share this, and you should see my screen over here, right? With I'm on the modules page for the server class. And if you look at week 6, it's here. Here's the PowerPoint. Here's the information for the lab. I have the lab open right now, but don't get too far ahead on the lab. You can, read it and download it and get it ready, but don't start the lab this morning while we're still lecturing, because I'm not going to have the capability to help you with that at this point. Okay, and then quiz 2 is also due this week. So if we go into quiz 2, and if you look at the time, it's available all week until Sunday at 11:59 p.m. Now, remember that there are everyone. Hold on, are there people in the waiting room? Okay, I don't see any. Anyway, I got a message that said there's people in the waiting room, but I don't see anybody. Anyway, this quiz will be available all week until Sunday night at 11:59 p.m. And it's 25 questions, open book, open note, but you can only take it one time. So once you start it, make sure you leave it open, and then do your research and answer all the questions in there. Okay. And then besides that, I've also, now, I wasn't really sure how much you liked or utilized the video that I created last week. If showing you how to do the lab, where I go through it kind of as a demonstration, if that's helpful or not, let me know in the chat if that's something that you think is helpful. Okay, because I'm not exactly sure if making those labs is better. That way you can go through it at your own pace. Oh, okay, some of you are saying it helped a lot, thought it was helpful. Okay, or if us just stepping through it together as a group, if that's a preferred way. I'll continue. I'll do a video again next week with our web services, just so that you can kind of see it. And with the Linux stuff, it's a little tricky because everything's at the command line. So it might actually help to see the commands typed out and then see them in the lab kind of spelled out. Okay, and someone says they prefer stepping through it together. So we'll mix it up. We'll do a little bit of both. All right, good. So any questions or comments on where we're at as a class? Now, this is week 6. We have quiz 2 this week. Next week is week 7. We're going to have the website creation. We're going to build a couple websites and some virtual websites and set those up using the Nginx in CentOS and then IIS in Windows. So you'll get a little hands-on on that. And then the 2 weeks from today is the midterm. So on the midterm week, during the scheduled hour, the 6 hours that we're together on Tuesdays from 8 until 2:40, that entire time is strictly for testing. So there is not going to be a lecture. There is not going to be a lab, not a instructor led any of those. But with that time, you'll be able to take the midterm and perform the lab midterm. And I'll have more details on that. I'll discuss that on Tuesday. We'll still have a meeting. I'm still gonna, be here, but really for that midterm, you have all week to do that. However, the lab, I would highly recommend you do the lab when you're used to doing the lab on Tuesdays. That way, if you do have a problem with your machine, you can reach out to me during that time frame when we're normally synchronously together, and I can assist you with that. Now, I can't help you solve your problems or help you create, the policies or create the shares or create whatever we're doing. I'll just say I'm not able to answer that. But if you have a technical, say something happens to your machine or, which shouldn't happen if we're careful, but so just be aware of that, okay? And so that's what's coming up. Any questions on where we're at or how we're going to get there? Okay, on the quiz, no, the quiz is just, everything's in the quiz. And then you can just look it up as you need to. Because they're just questions that I pulled out of several different test banks that are very general in nature. Some of it will be about Windows Server, some of it will be about VMware, some will be about some of the material we've covered in the class. So you're pulling that data from a multitude of sources, the class notes, the lecture material, the labs that we've done, and then just VMware's search and searching Google for server stuff as well. So good question, Ian. And then if there's fill in the blank, I'll go back through and manually grade those just like I did on quiz 1. And that normally, if you get a 20 on when you submit it, normally those go up 3 or 4 points at least. Okay. Any other questions or comments before we get started on the lecture? I'm looking over here. Okay, Louis says nope. And away we shall go. So let me share my screen again. And all right. So hopefully you can see the lecture material here on the side there. But today we're going to kind of dive into how ESXi and VMware deal with storage. And as you probably know, or if you haven't really formalized these thoughts, but they've probably been informal in your studies and interaction with any computing device, but storage is a big deal, right? And especially in our virtual environment where we're cloning a VM that may be 2 to 4 gigabytes in size in its smaller version. and we're allocating 40 gigs or 60 gigs of hard drive space per VM. So when you look at our environment right now, we have 4 servers in there, or 4 machines, and we're going to add a 5th today, and then we're going to add 6, 7 more, or 2 more next week, and then for the midterm, you'll create 2 more. So that's a total of 9 VMs at 60 gigabytes of space. That's what, 540 gigs of hard drive space just for a little test server, right? And if you're in a production environment, those hard drives may not be just 60 gigs, right? So for example, the file share we created last week, because we use the hard drive of our Win server dash domain controller to create the share on, that hard drive, the share size is only 60 gigabytes. And for a typical network file share, 60 gigabytes is not big enough, right? We're talking, network shares that are in the minimum of 1 or 2 terabytes. So that 60 gigs is really, really small. So as we add more functionality to our network and to our server infrastructure, the ability to share files and move files around becomes super important. So how we add storage now, it's typically not beneficial to just power down the server, add another hard drive into one of the internal drive bays, fire it up and go for it, right? Because, just like with the fault tolerance things that we were talking about with VMware and some of the disaster recovery and business continuity we talked about last week, we want to kind of eliminate the possibility of a single point of failure with a server failure. So if that server goes down, all the storage in it goes down. So we want to move our storage to either storage area networks, which are SANs, or the network attached storage, which are the NAS. Okay. So when we look at this, we're going to kind of have to look at where this can occur. All right. So storage is always critical. When you build a computer, or when you update a computer, or you start working for a company and you're supporting all their computers in their server environment, you're going to want to get a good grasp on what are the storage needs and how are the users utilizing that storage space. Okay. So designing it from the beginning is always easier than coming into it after, right? It's kind of like if you're looking to purchase something and you decide to save some money and buy a used version of it, there may be things you have to, update, maybe things you have to change or modify. Whereas if you buy it new, normally you can design it in a way that it includes everything you're looking for from the very beginning. Okay, so that's the same concept with our network storage. So when it's always important, but it came even more so as vSphere is used for larger workloads, for mission critical applications, and for really large clusters. So remember, our clusters are typically, when we say the word cluster, we're talking about a fail over cluster as opposed to a network load balanced environment. But a cluster is designed with the sole purpose of redundancy and availability, right? So as we do that, it becomes very important that we figure out our storage pretty expertly. Now, there's some advanced capabilities that we've already talked about that vSphere includes. That includes the high availability, the DRS, the fault tolerance, site recovery manager, and so forth. Okay, Now, there are some real benefits when it comes to performance that we can design into our environment by using either fault tolerant devices like RAID. RAID can improve performance of our disk subsystem, and it will, if we improve our hard drive, we typically improve the performance of the virtual machine. And remember, the goal of our virtualization project, or why do we virtualize, is we want, a simple orange monster, the availability, scalability, optimization, and management. We want those servers that are virtualized to perform as if they're regular machines. I mean, if you were to virtualize and everything was 20% to 50% slower than it was on actual hardware, you probably would pull the plug and say, this isn't worth it. So the performance aspect, we can fine tune this with our design of our storage, okay? And then the availability allows us to have our machines that will either with high availability where we can move them whenever needed, or we can have it do it automatically with the DRS and the fault tolerance. All right. Now, the server design choice can start in the beginning with the type of hard drives we purchase and use, and B, what our external storage design will look like. So when we start talking about hard drive performance, that can really make the difference between success and failure of a virtual environment. I mean, if your company, let's say you work for a company and they say that they want to move everything to the cloud, which we know now the foundation of the cloud is virtualization, and you move to the cloud, and then all of a sudden, all of your performance is super slow. And it was fine when it was on premise, but in the cloud, it's slow. There's a couple of areas you would look at first, probably the network, the bandwidth issue between you and the internet. And the second one would be the hard drive performance. Now you can do something about your bandwidth, right? You can pay for a bigger pipeline, a bigger internet connection, but there's not a lot you can do to have, say, Amazon Web Services or Microsoft Azure. You can't really call them up and say, hey, on the server that my virtual environment's on, my cloud is on, can you update those hard drives from 7,200 RPM to 15,000 RPM? Or better yet, can you make them all solid state drives? They're not going to do anything with that, right? So where we put them is very important. So this is true whether we're using SANs or NASs. Now, the SAN and NAS, I mean, obviously they're all the same letters, just the design is much different. So we'll define that here in a few minutes. Oh, went too many. Okay, so the requirement is unique for every virtual machine. Some virtual machines, hard drive performance is an important part, but it may not be the most important part. Whereas other virtual machines, the hard drive performance may be the number one concern of that virtual machine. So for example, if we're doing just an Active Directory domain controller, right, where it's providing our user authentication and authorization and accounting, right, our AAA with Active Directory, we are not probably focused on hard drive performance for that environment. We'd be more focused on high availability, right? We never want to see our domain controller go offline. So availability and fault tolerance would probably be number one on our list of requirements for a virtual machine that's hosting our domain controller versus a SQL server or a database transaction server. In that machine, the speed of the hard drives is going to make or break the functionality of that environment. Okay, so different utilizations, different use cases will dictate to us what type of hard drive system or disk input output that we'll be really looking at. Okay, now we can have, in the slide it says light utility VMs with with few storage performance considerations to large database workloads where it's incredibly important that we have good storage layout. All right, does that make sense? I mean, for even in our home computers, the lag time or the slowdown on a typical machine is still the hard drive, right? Our memory, our processor, our network are typically running at, in our controller buses, right? The input output buses of USB, PCI Express, any of those buses are at such high speed, but the hard drive performance, especially if we have a hard disk drive versus a solid state drive, that is still the bottleneck. So the same thing is going to be true in our servers. All right. So here is a good graphic that shows a storage area network or some form of shared storage between all our virtual machines. And what can somebody tell me about this design? Where is the single point of failure? If this fails, what happens to our network? So let's just start with the VMware ESXi with the VMs on the left side. If this host machine here, so let me turn on my laser pointer. I'll do a pan. So this VM here, if this host server, if this goes down, who's affected? Just these VMs, right? Anybody in this VM or this one, all of these VMs are going to go offline if this server goes down. But all of these VMs are fine, these are fine, and anything on this disk subsystem is fine. Okay, so let's undo that. Get my eraser. So we'll re-erase that. And what happens though if this network connection here goes down? So if that is our single point of failure, if we look at that, again, it's just these VMs and nothing else. Okay, so as you can kind of bounce around on this screen, you can start to see that our biggest point of failure is going to be this network or this disk subsystem. Because where is this VM storage? Well, this VM storage is on this disk. This VM storage is on this disk. This VM storage is on that disk. Okay, so if this area goes down, all of a sudden everything goes down. So what are some things? Pop into the chat and tell me what are some of the things that we could do to prevent downtime in this environment? Where would we want to build up some sort of redundancy? You can unmute and mention it too into this. Okay, so Ian, you said have a secondary storage on our side of the network. So where would that so you're saying that we should do something like this, just have a second SAN over here? or whatever that is. You okay? That's an option. That's a very expensive option. Some of these SANs can, especially larger ones, are pretty expensive, but that is a good option, right? Have a redundancy there. Where else would we want to have redundancy on that? Now, if we had this SAN and it was connected to the same network, then our network becomes a problem. So we'd probably want to build redundancy into our servers where they're on a separate SAN network as well, right? Just to kind of complete the thought there. All right, where else could we have redundancy that would help us prevent this disk system from having issues? It's actually on the diagram. You can see it in that SAN. You see all these disks, right? All these different disks that are in this storage array. Those indicate that those disks are actually a part of a RAID system. Exactly, Louis. So the redundant array of independent disks, those disks are probably hot swappable. So if this VM, let's say this VM here is connected to this set of disks that are set up in an array. So if disk 1 fails, so if this one goes down, the other 2 disks, let's say it's an RAID 5 array, they will still support the sharing and the functionality of the hard drive subsystem. So it will not go down. It can withstand a disk failure and still function. Now it's going to function in a deprecated mode while it attempts to rebuild the array. But once the array is rebuilt from a hot disk, it will perform just like it's supposed to with full speed. Okay, so there are a lot of considerations to this type of a design. So let me clean this up with my eraser. No dot there. All right. So all right. So the design here is critical. Now it's immediately apparent that the ESXi hosts and the VMs are going to contend or compete or look to use the same channels, the same pipelines, the same network connection for the shared storage asset. And at first glance, this may look a little bit like we don't, we're not taking that into consideration. So, but in actuality, this design is typical for our storage area network. This is a back channel network where only the servers can get to that and the VMs on those servers. The users, the client access would typically be coming in from the top here. So we'll have our clients will come in from this direction into the VM. So be another network up here that our networks will connect to, our clients on our network. Okay, but the capabilities here is when we design the storage solution, we're going to look at various disk attributes such as the capacity in gigabytes or terabytes, or after terabytes we have the petabyte and then exabyte, and the performance, which is measured in bandwidth, which is the megabytes per second, or the throughput, which is referred to as input output operations per second, or IOPS, and then the latency, which is the delay or the time it takes for the data to move from the disk platter or the disk storage to the disk controller. And that's typically measured in milliseconds. And then, of course, we always want to think about the availability, the redundancy, and fault tolerance. Okay, so when we start digging into the design of our shared storage, we want to keep all these fundamental thoughts in the forefront of our thought process. Okay, now, how can you determine what your performance requirements are? Well, one, you should have a general idea of what your virtuals are going to be used for, right? If they're just going to be used for, say, remote desktop support, so your user are just going to remote into them and then work on their machine as if it's their workstation remotely, like we kind of do with our Guacamole server. The speed of our network and the speed of our hard drive performance is probably not the most crucial. Availability would be more crucial, right? But if we're logging in to do, say, video rendering, or we're logging in to do huge transactions on a database system, then the speed of our hard drives will become even more important. Now, if we're transferring a lot of data, so large files, say we're doing video work, and we need to not only create these large files, but we need to move them from memory to the hard drive, or from the hard drive to the memory to the network to another machine, then the latency would be a very, very important factor. And then, depending on our system, the speed at which our hard drives actually operate, right, with the input output per second, that would become the factor. And then, of course, the size of the disk is always a factor. We wouldn't say, well, let's just put a 5 gigabyte drive in this server, and then the first file we work with is 10 gigabytes inside. It's not going to work, right? You're going to get an error out of disk space. So all of these things have to be kind of rolled into what we're trying to do. All right, does that make sense? I know I'm kind of beating this topic to death with kind of asking you to understand this, but it's crucial. This is crucial to the success or failure of our virtual environment. All right. So what does vSphere itself need? So to run vSphere's ESXi, it really, it depends on what the VMs need. So we can't necessarily answer this. This isn't a cookie cutter question where you say, cut out one cookie and then do it again, and all of them are the same mold. That's not going to work right. That's not going to fly in this type of environment. So in other words, the needs of the vSphere is the aggregate sum of all the needs or the use cases across all the VMs. Now, VMware, of course, they sell a product that will help you with this called the VMware Capacity Planner. So this is an add-on that you can purchase from VMware, and it will help you determine this. So they have use cases where you can just kind of click and say, okay, I have this many virtuals that are going to be doing these types of functions, just kind of general functions. And it will come back and spit out and say, well, this is the hard drive design, the storage design that we recommend. All right. So when it comes to performance, the stability of the environment and the VMs depends on the same shared storage infrastructure. So a robust design is super important. It's paramount. Because we know no storage means no VMs, which means no good, right? You're going to have some problems with your performance review and your job likelihood of retaining your job if none of your VMs work because they don't have any storage, right? That's going to be a bad mark on you. So you want to make sure that we give this some consideration, right? So traditionally, the server that we designed, the storage that we were talking about was local storage. And by local storage, I mean the disks that are built into the server itself. So like if you take your home computer and say, if you disconnect your USB drive or your network connection and say what storage is local to that machine, you're talking about the hard drives inside of it. So traditionally, the local storage on our vSphere ESXi has been, it's used in a very limited fashion because all of the features of vSphere's advanced features like vMotion, high availability, fault tolerance, DRS, the main requirement is that it uses some type of shared external storage. So the design consideration of, so if you were going to say, you know, I want to buy a server and do all these labs at home, right? I'm going to go on eBay and buy a server. What hard drive, how big a hard drive does that server need to run ESXi? And the answer is internally, it doesn't need any hard drive. It can run, and in fact, our servers are set up so that they're actually running vSphere's ESXi from a thumb drive. So all those servers, I took a little thumb drive, right? Right. So here's a thumb drive. I don't know if you can see that. So this is a 32 gigabyte Lexar drive, and on each one of these, I installed the ESXi 6.5 hypervisor. So when those machines, those servers boot, they boot from the hard drive and load ESXi right from the thumb drive. And the internal hard drive, which on our machines is that 1.8 terabyte hard drive, that's what we're using for our data store. Okay, so for our data store, it's local, but our actual hypervisor is running from a flash drive. Okay, so what if you don't have any local storage, no USB, no internal hard drive? Well, then we can use a diskless blade system, right? And they make some of these systems that can actually boot and load an operating system, hypervisor, you know, VMware's ESXi, from a shared network drive. Okay, so there are a lot of options to get our storage or our hypervisor running, and with very, very little hard drive space. So just as a way of comparison, the hard drive or the flash drive, the thumb drive that I'm using to boot all of our ESXi servers is only 16 gigabytes. So those are small thumb drives by today's standards. So you don't need a big thumb drive to do that. Okay, and that's a typical design. A lot of ESXi will boot from those thumb drives. And then what they do is once they have the ESXi server set up, they power it down and then they clone the thumb drive. So if something happens to the thumb drive, they can just take it out, put in the clone, pop it on, and away you go. Everything's running again. So it's a very, very clean way of doing that. Okay, now shared storage is the basis for all of our vSphere environment because it supports the VMs themselves, and because it's a requirement for many of vSphere's features. Their advanced features almost always are going to need shared storage, right? So the elements that make up a shared storage array consist of a couple different things. One the external connectivity, the network connectivity, the processor in the shared storage box, right? And these SANs are like standalone computers that have their own processor, and they also have the array software, the cache memory, the disks, and the bandwidth. Okay, so when we think about how do we connect to our shared storage, the first thing we need to look at is what type of network are we going to design? And there are really two network design. One is our traditional Ethernet networks, which is what we're familiar with, right? That's typically our category or our fiber optic Ethernet connectivity. And then there's a specially designed fiber channel, which is a network designed with fiber optic networking, but it's unique to the controller and the network card that we put in. It doesn't work on the same Ethernet cards that we're used to. Now, the characteristics of this connectivity define the maximum bandwidth of the communication between the ESXi host and the shared storage array. All right. So the first thing we want to look at is the external connectivity. How does our host communicate with storage? And what is that link? So we want to make sure that is robust and typically as fast as we can afford. Now, some of these systems have gradually increased the minimum requirement. So for some of these systems, the minimum network connectivity is 10 gigabytes. So that's a 10 gig connection, which is not common on our enterprise networks today, right? Most of our enterprise networks are 1 gigabyte. You can purchase 10 gigabyte switches and network cards, but it's extremely expensive. And most of the time it's going to precipitate that we upgrade our cabling, because if it's Cat 5 or Cat 6, it's only going to go up to 1 gigabyte. And if we want 10, we're going to have to upgrade it to Cat 7 or fiber optic. Okay. And that starts getting expensive. Now, in the storage array system, so let me pull up a image search here. And so here I just went to Google, and oh, it's on the other one. It's on the right one before. You can see here some of these storage arrays. So here's a Hewlett-Packard one, and some of these smaller ones are inexpensive, but some of these bigger ones can get expensive very quickly. So here's a Dell 12 terabyte SAN, and it's $53,000. This one doesn't really say what it is, but it's the fiber optic input output, and that's 113,000. So yeah, the pain, right? By pain, you mean expensive, or is that an acronym for something, Luis? But it is expensive for sure. Yeah, exactly. So, but when you look at some of these connections, so here's the front end of the connection. These big cable, these are power cables, and then the backside, and they don't show it, but on the bottom here, down a little bit farther, is where the network connectivity is. So these can add up very, very quickly. So let's go back to our PowerPoint. All right. Now, those boxes, they're like computers, and inside of the system, there is going to be a processor. So different vendors have different names for their processors, which are considered the brains of the array, right? They're the brain, just like our CPU is the brain of our system. Yeah, you could buy a house if you had 5 of those. So the processor handles all the input output and then run the array software. So there's a operating system built into these systems that allow us to configure the array and build the array, the system. Now, in most modern arrays, the storage processors are not purpose-built application-specific integrated circuits. So that's referred to as an ASICs, but they're generally general purpose CPUs. Some are going to use Power PCs. Some may have a specially designed processor for them, and some are custom ASICs for special purposes. If you cracked open an array, you would most likely find an Intel or an AMD CPU. Now, it might not be an i7, it might be a special Intel processor, or might not be a Ryzen, but it will be some type of an AMD processor that's custom made for the array. Now, as I'm sure you're aware, you can build your own SAN using free open source software and typical hard drive and computers hardware that you have lying around your shop or around your house. So the one I use, and when we go to that 10.28.72.50, that's an array, that's a SAN that I've designed using open source software called free NAS. So it's free than NAS, which is, it can do both NAS sharing and storage array networking, which we'll unpack the difference of that here in a little bit. But the processor inside of that machine is actually an Intel processor. All right. So besides the network connectivity, we need to think about the CPU, because we know if the CPU is severely underpowered, it's going to affect the performance of the SAN, right? The entire network is going to be slow because the processor is slow. So we want to consider that. The software that we use is important. Normally, the hardware attributes are very important, but the array software can also have some limitation or functional capability limitation of our storage area network as well. All right. Now, the amount of cache, the cache memory on both the hard drive and the processor, we know that cache is that area of storage in our memory systems where when the processor needs information or the hard drive storage controller needs information, it'll put it in this high-speed memory so that the link between them is fast as possible. So the cache memory will help us with that. And the faster the cache, the lower the latency, and the faster or higher the input output per second will be, because it's going to buffer or store that information in the cache memory. So the more cache and the faster the cache, the faster the performance is with the IOPS, and the lower the latency is because there's no delay. Okay, so all this has to round out into what we will hope is our optimal performance. Now, the type of hard drives, the disks that we use, and these disks are often referred to as spindles in this environment. So different arrays support different disk types, and they will allow us to scale up or scale down our drives. Now, normally our hard drive space only scales up. Rarely, if ever, do we say, well, our file share is too big, let's reduce it. I mean, if we thought about it in the beginning and gave it some design consideration, we're probably going to be okay. It's only going to get bigger. It's not going to shrink. So the drives are really described, when we just describe the disk drives, there's really only two attributes. The first, drives are often separated by their interface. So how do they connect to our disk subsystem array? Are they going to use fiber channel? Are they serial attached SCSI or SAS? Or are they SATA? Okay. Now, non-solid state drives also are going to have the attribute or the description of their rotational speed. So their RPMs. So we may say it's a SAS drive at 15,000 RPMs. So those would be the two descriptions. Okay. Now, solid state drives have no moving parts. Therefore, there is no RPM. But on our SATA or our SSDs, we still need to know, how does it connect to our array? Is it going to be SAS, SATA, fiber channel? But there is no description of its speed because that's built into it. All right. So different disks will have different speed, which will allow it to have a different or a varying input output per second. So a typical SATA hard drive. So this is if you see RPM, that means it's a spinning hard drive. If it's at 7,200 RPMs, the input output per second is 80. Okay. A SAS drive, which is serial attached SCSI, or a fiber channel connectivity. So that's how it connects, is with the SAS or fiber channel at 10,000 RPMs goes up to 120 input output per second. If it's SAS or fiber at 15,000 RPM, it's at 180 input output per second. If we use a standard SSD, which has no RPM, right? There's no moving parts. Its input output second is somewhere between 1,000 and 2,000 input output per second. And then our enterprise flash drive, which is these drives that are designed specifically for SSD for SANs, you could call it, they're going to have a input output of between 6,000 and 30,000 input output per second. So just look at the scalability of how those increase. Now, Alan, you asked about an M2. An M2 would be in the SSD category, not the enterprise flash, but in the SSD. So it's going to be almost 10 to 20 times faster than a typical hard drive, right? So if we had the SAS fiber channel 15K and we go to solid state drive, it's the input output per second is almost 10 times greater. So most of us have experienced this, right? How many of you remember the first computer that you upgraded the hard drive and you went from a typical hard disk drive, a spinning disk, to a solid state drive, and right away you notice, boy, Windows boots up significantly faster. My programs open significantly faster. Things shut down. Anything that had to do with hard drive was light years better, right? Yeah, and you can't ever go back. There's no going back to a system that doesn't use SSD. You're right on about that. Okay, so when we talk about input output, remember the two attributes we're always going to look at is how does it connect to the drive, to the array, to the controller, and then how fast is it with the RPM, and then what is, and that will lead us to the discussion on input output per second. All right. Now, different drives are going to be, they're going to perform differently depending on what data is moving across them. So when there's large block, which means that the chunk of data is in a large size, and the system has to do things in a sequence. So transfer all this data and then do this next section of data and so forth. The performance is going to be more consistent, right? And that makes sense. If you were unloading, say you work for UPS and you're the night shift that loads and unloads trucks, if all the boxes were the same size and you knew you could put, okay, I can stack 6 of these boxes, put it on my dolly truck and wheel it off, go store it over there, bring it back, do it again, do it again. If it's consistently the same size, your performance is going to be consistent. But if the size of the packages or the boxes are all different sizes and they're all located in different areas of the truck, that's going to have an inconsistent performance, right? Certain loads will go faster than other loads that you're moving around. Okay. So if we know that our block data is going to move in a consistent manner, so if we know what the data is going to be, that's a good location to consider inexpensive SATA drives. Okay, that are, because we don't need a huge input output per second. We just need it to work consistently. So SATA drives would deliver strong performance at a low cost, which is something we would want to consider. All right. So those are the features of the hard drive that I wanted to talk about in the beginning here. And then it's almost 9 o'clock, so we're going to take our first break. But when we come back, we'll continue and we'll start by looking at some of the RAID features. Okay, so we'll explain RAID. So for those of you that may not have a lot of experience with RAID, we'll set that up. Now, one of the labs that I typically do this week is when we're in person, and this is just one of those things I have to, cut out of the curriculum because of distance learning, is we build, I have about 6 or 7 older servers that I have available to us. And then I have 4 SANs from QNAP that we actually do groups. We break into small groups, and we build the array, starting with building the RAID volume and then setting up the iSCSI transport and then connecting our ESXi host to it. There's no way to do that remotely. I even considered asking if I could use one of the rooms and we could just go up there in groups, small groups, and they said no, unless everybody goes through the screening process and all that. It just was not tenable for us to do. So that's one thing I had to eliminate from what we're going to do this semester. But traditionally, we do something like that. Now I'll look for some videos that show how that works, and I'll add them into this week's module. when I find them, so you can at least see how that's done. Okay, so it's let's call it 9 o'clock. Let's come back at 9:10, so about 10 minutes from now, and then we'll keep discussing the disk subsystem and the storage of our virtual environment, and we'll come back by talking about RAID. All right. So for those of you on the slides, we're on slide number 22. All right. So I'm going to pause the record. All right. Well, welcome back from your break anyway. Some of you probably didn't go very far, but I just went to warm up my coffee. I'm back, so assuming you did about the same. All right, so let's get back into the lecture notes here. Let me share my screen again, and let's have a brief discussion about RAID. Now, how many of you have done any kind of RAID arrays, whether it's RAID 1 or RAID 0, 1, 5, 1, 0? Have any of you ever done that? Nope. Okay. Not yet. Okay. Now I know, like in the CNET50 and CNET60, some of the materials we use, like with testout.com and then Cengage's MindTap, they have some simulated RAID arrays. And then in CNET52 and CNET54 and CNET 56, we actually build some arrays in our virtual environments when we're face to face. So this is an area that is very common, right? And the redundant array of inexpensive disks is a fundamental and critical method of storing the same data several times. And remember, redundancy is one of our first lines of defense against our single points of failure. And if we were to prioritize what is the most important thing on our systems, it's always going to come down to the data, right? So the data, the information that is stored on our systems is always one of the things we want to give our highest priority of ensuring that it's there. So RAID is used to increase data availability by protecting against a data or a disk failure. And it allows us, by combining these disks together, we can improve the performance compared to a single disk. Now, somebody referred to this, a hard disk being similar to a pilot that's flying a 747 at 600 miles per hour, 6 inches off the ground. That's what our hard drives are doing, right? They're spinning, the hard drives, not solid state drives, but our hard drives are spinning at 15,000 RPMs, and that read-write head is just millimeters, micrometers above that data. So as this is spinning, this read-write head is right above it. That'd be like flying a 747 at 600 miles per hour, and the highest you ever get is 6 inches above the ground. So imagine flying from here to Seattle, and you can only be 6 inches above the ground, and your pilot would have to go up and over, and you wouldn't make it very far before there's a catastrophic failure, right? So RAID is designed to do just that, because we know that disks will fail. It's not a question of if, but more of a question of when. So remember, all the RAID protection in the world won't protect you from an outage if the connectivity to your host is lost. So if you don't monitor and replace failed drives and allocate drives as hot spares to automatically replace failed drives, of it, the entire array is lost. So you always want to make sure you're monitoring that. And there are job descriptions where part of, say, a server technician or a PC technician, their job is to literally walk through the data center, and they have this clipboard or a tablet with, you know, electronic information on it, and they'll just walk through and they'll monitor all the servers, and they just look at all the lights, and they just go up and down the server racks. And if they see red lights, green lights mean everything's good, red means there's a problem with the disk. And then what they'll do is they'll annotate it, or on their iPad, just, you know, touch the button, and then it will send a help desk ticket to a technician, maybe a different technician, or maybe the same one. And then they'll come back through the system, and they'll have a cart full of disks, and they'll just go to the server and they'll pop out the disk, put in the new disk, and then the array will automatically rebuild itself. So their job is literally just disk inspection and replacement. Okay, so that is a way to do it. Now, we also need to consider disaster recovery, because if all of our data is on a RAID controlled system, but that system is in our data center, and the data center is flooded, like, say, you know, with all the rain and the rivers overflowing in Nashville. You've probably seen this on the news in Tennessee, right? They just declared a state of emergency because of flooding. So imagine our data warehouses over there, and all of a sudden all these drives that we've been so diligent to set up and make sure they're perfect, but if it's underwater, I mean, we need to have a disaster recovery plan as well. Okay, so RAID levels or RAID arrays are categorized by numbers, right? And we have RAID 0, RAID 1, RAID 5, RAID 6, and then RAID 10 or RAID 01. Those are the most common. There's RAID 50 and 60 as well. Okay, now with RAID 0, there is no redundancy. So with RAID 0, the disks are only paired together to increase speed. Because if I have multiple drives, okay, so in this screen, I have 4 hard drives. With RAID 0, the first hard drive, this read-write head. So you see this little mechanical arm here with that has this a read-write head. This has a little magnetic sensor on there that can magnetize or demagnetize the magnetic surface of the disk platter. And these disks are spinning, and then the read-write head just moves. So if I have 4 disks and I want to write the data 1011, this disk read-write head can write 1 at almost the exact same time. This can write 0, this can write 1, and this can write 1. So that's faster to have 4 disks with 4 independent read-write heads that can communicate with the disks faster than if this single disk has to write 1, 0, 1, 1, right? That's going to take 4 cycles, whereas this one can probably do it in 1 cycle. All right. So RAID 0 will improve our speed, but the problem is if this disk fails, so if disk 1 fails, I can't write or read 1, 1. I mean, that data, whatever data is stored in this binary code is gone. So there is no redundancy with RAID 0. The only benefit is the speed increase. So RAID 0 is commonly paired or used with other RAID levels. Hence RAID 10, RAID 01, RAID 50, RAID 60. So really that's going to add the benefit of the redundancy from the other RAID level with the speed increase of RAID 0. Now another term for RAID 0 is striping. So you may see the term may say that the data is striped. And what that means is that it's on a RAID 0 array. Okay. And then the next level is RAID 1. And then this is also part of RAID 10 and 01, where the data is actually copied from one volume to another volume. So, and that's known as a mirror. So RAID 1 is mirroring. Now, it offers the highest degree of protection, but it's going to cost us, we need twice as many hard drives. Okay, so RAID 1, and I don't have 1 and 0, but just assume that in the middle here, let's just say we only have these 2 disks. Now, with RAID 1, we have to have an even number of disks because you can't mirror something to something smaller than the original size. Okay, so this data, RAID 10, is written on this disk, and then it's mirrored to this disk. And then 11 is written to this disk, and then it's mirrored to this disk. So you see the mirroring is on these 2 disks. So this data, this 10 is mirrored onto this disk, and then 11 is mirrored over here. And then this 1011, 1011, the 1011, these are striped across these 2 disks, right? That's using RAID 0. So that's why this is RAID 10, because it's mirrored and striped. So we get the performance of striping and we get the redundancy of RAID 1. So the mirroring, okay? So but the cost is we're using twice as many disks, all right? RAID, parity RAID, which is RAID 5 and RAID 6, they use a mathematical calculation to represent the data across several disks. So let me do something here. And do a new slide. I'm going to just do a blank slide here. All right. So if I, let me change my pen color. Let's go with here. So if I have x plus y equals z, right? If I tell you that x equals 1, y equals 2, and ask you to solve for z, you can do that pretty easily, right? So 1 plus 2 equals 3. So if I know 1 plus 2, I can calculate what's missing, right? Now, what if I said 1 plus question mark equals 3, or question mark plus 2 equals 3, right? So here I have a missing value, missing value. So in really simple terms, parity is the ability of the RAID controller card, right? Remember, we need a processor, and this is where this is gonna be done. It's going to say, if you have data on this disk and on this disk, I can calculate if this data gets damaged, I can calculate what it is because of the parity calculation. I know how to calculate what's missing. Same as this. If this disk is good, but this disk fails, I can calculate what's missing with some simple mathematics, right? Some calculation. And the same thing here. If this disk fails, I can use the two values to calculate what's missing. All right. So RAID 5 uses a mathematical calculation to represent whatever data is across several disks. So RAID 5 is, here we have a total of 4 data is written across 4 disks. And then we have a 5th disk where this calculation, so we'll use whatever the formula is to get our parity. And the first time through, it'll be 1011 and then the parity calculation. The next time, so that let's say this is the first time, the second time it writes the more data, it will go 101P and then the last one. And then the third time it was 10P11, and then the last time will be 1P011. So assuming we're writing 1011 multiple times, that's our data. So if this disk fails, this entire disk fails, I can rebuild with what's missing because I have a parity here, here, and here that I can rebuild whatever is missing from this disk. Now, this last one, I don't have to rebuild anything because I have the data already. It's not damaged. So with RAID 5, you can experience a single disk failure and not lose any data. Now, the controller, this processor will have to rebuild that data by using the parity. Okay, but there's a cost. The cost is it takes time to calculate the parity. So read performance. So when we're reading data, it's normally very, very good because a large number of drives can be read from, but the writing takes a little longer because it has to calculate the parity. Okay, so those are our RAID levels. And then RAID 6 has double parity. So normally they show it with a P, and then the second parity normally is Q. So this would go 1011 PQ, 101 P, 1Q, and it will just move the P and the Q all over the place so that if a single disk fails or 2 disks fail, with RAID 6, you can survive 2 simultaneous disk failures and the data is still recoverable and usable. Now, most servers, when RAID is running, it only sees the array as a single volume. So this is normally, especially when it's done with a hardware-based RAID. So with hardware-based RAID, we have our RAID controller card, and I'll go to RAID 5 here. We have our controller card here, and then each one of these disks is connected to the controller card. So if this disk fails, the controller card can calculate what's missing on the fly, but the performance will go down. And then if we have a hot swappable disk, so here's our hot swappable disk, it will automatically rebuild this data as it calculates it. And then eventually this disk that has failed, we can just come by and replace it. And then it will just rotate into, now this is my hot spare. So this disk becomes disk basically 1. So remember, we started 0, 1, 2, 3, 4. And then this disk becomes the hot swap. So it's a really good way to ensure that the data is always available. Now, for most vSphere settings, for what we do in vSphere, RAID 5 is a really good balance. It has both capacity, efficiency, and performance and availability. Now, typically your RAID storage infrastructure will be made up of multiple RAID types. Some of them we may just need striping. And RAID 5 has striping, right? This data here is striped, and then the parity is striped as well. And then it just moves it to the different disks. So we do get the benefit of the striping. And then because of parity, we have the redundancy, okay? Without having to double our hard drive space like we would with the RAID 1. All right. Now, there is a service that is also included in vSphere, which is known as vSAN. And this started with vSphere 5.5. And with vSAN, it pools the locally attached SSD storage. It can only be solid state storage. And it will say on host 1, we have a gig or a terabyte of solid state. Host 2, we have a terabyte of solid state, 3, 4, 5, and it will pool or aggregate all those together and build a virtual vSphere SAN. And it will cluster and then present back to the pool all of the data. Now, this is a separately licensed product, right? Remember when I said I'm selling you vSphere? This is something you would have to buy to do that. And it requires solid state drive in the server, okay? Now, vSAN does not use its own traditional RAID. They have their own terminology, their own RAID array called RAIN, which is the reliable array of independent nodes. So instead of the redundant array of independent disks, it's a reliable array of independent nodes. And with RAID, so here, this shows where we have 2 hard drives. Now let me go back to my red color. So in each one of our host machines, we have 2 hard drives, right, that are attached to it. And only the solid state drives could be used for the RAIN array for the vSAN. Okay. All right. Any questions on RAID? No? All right, good. All right, so what about how do we design this? I mean, how do we put all this together? What makes sense as we go through this? Now, there are a couple of design systems we can do, and it refers to how the different arrays communicate with each other. So the first one is active-active. And with active-active, that means that there is input-output on all of our storage processing. So this SAN and this SAN are clustered together, active-active, and they'll work together. So that's similar to the network load balancing. And then an active-passive is where we have one node that is actively processing the data, and the other node is in standby mode. So that's typical of our failover cluster. All right. So active, 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 passive. Now, vSphere, they come in and they kind of redefine this a little bit. So in vSphere with the vSAN, they define active, active as the system provides access to the LUNs, and the LUN refers to the logical unit number, okay? Simultaneously through all available storage ports without significant performance degradation. Barring a path failure, all paths are active at all times. And then vSphere defines active passive as one storage processor is actively providing access to a given logical unit number, and other processors act as backup for the LUN and can be actively servicing input output to the other LUNs. In the event of the failure of an active storage port, one of the passive processors can be activated to handle the input output. So unlike our traditional active passive, where one is just literally in standby mode, in vSphere's active passive, they're in standby for the original active, but they're also processing their own storage input output. Okay, so it's a little bit different with vSphere. Now, VMware's definitions are based on multi-pathing mechanics, not whether you can use multiple processors at the same time. So that's kind of the definition there. All right, so this gets us into, now that we kind of know what it is and how the data is written and read and written to the devices, now let's talk about how the data moves between the storage array and the vSphere ESXi host. And that's going to talk about the storage protocols. And you probably remember the term protocol refers to the common language that the two nodes, the two connectivity points, if they're going to communicate, there has to be a shared language of some sort. Okay. So just like if you go to a foreign country and you don't speak the native language, like say you're in, Israel and you don't speak Hebrew and they don't speak English, you're going to have to, come up with some sort of communication technique. And that's exactly what a protocol is it's a shared communication method. Okay. The three most common, and there are some other ones, but these are by far the most common, are fiber channel, iSCSI, and then the NFS storage protocols. Okay. And all of these are available in VMware. So with fiber channel, it's a proprietary fiber optic communication. So the connector card in the storage array and the connector card in your server have to be from the same manufacturer. And then the fiber optic cable is probably going to be proprietary as well. So fiber channel was really the first protocol used with storage arrays, and they were designed to take advantage of the older hard drive system, which is the SCSI. And SCSI stands for Small Computer System Interface. So SCSI was a hard drive. So go back, 20, 25 years, and hard drives were two types. They were either IDE or parallel ATA, or SCSI, which was the Small Computer System Interface. And the SCSI was typically found in our servers. And the benefit of SCSI is the instructions for SCSI that are built into the hard drive controller are very small and very fast. Whereas ATA, PATA, and SATA, the controller the instructions that are built into the controller card are a little bit longer, so it takes a little bit longer. So SANs were designed to take advantage of the SCSI system because it was faster and easier to implement. Okay, so they mimic that. Now, a SAN is a network where storage devices, which are logical units or LUNs, are presented from a storage target, which are one or more ports on an array, to one or more initiators. And the initiator is usually the host bus adapter, which is the card, right? The internal expansion card that we put inside of our server, or it's integrated into the motherboard. Now, an initiator is usually that, or it can be a converged network adapter, which is a CAN. Those software-based initiators are available for iSCSI and for fiber channel over Ethernet. And I know there's a ton of acronyms coming your way, okay? A lot of this information, if you see a question on quiz 2, or you see a question on the midterm about this, I just highly recommend you look it up, right? That's why these tests are open book. All right. Now, the oldest one, the first one was fiber channel. And early on, fiber channel was extremely proprietary. So if you bought a Dell fiber channel SAN, you had no other choice but to buy a Dell fiber channel network card and buy the Dell fiber channel cables. Everything had to be from Dell, and it had to be for that particular model. If you interchange those, like say you had an HP SAN or a QNAP SAN and they were fiber channel, and you said, well, I'll just use this, it wouldn't work. They just did not work very well with other vendors' equipment. That's no longer true. So now fiber channel is pretty universal. So with fiber channel, it assumes first you have a very high bandwidth, which means we can transfer a lot of data at a very high speed, and it's going to go at a very low latency, and there is no loss going through the physical layer. So the physical layer is referring to the OSI model, where the physical layer is layer 1, right? So that's fiber channel. Now, there's 3 modes for fiber channel. There's the point-to-point, which is designated fiber channel dash point-to-point. There's an arbitrated loop, which is fiber channel dash AL, and then switch, which is fiber channel switched. Now, the point-to-point's rarely used. The arbitrated loop is sometimes used, but the switched mode is the most commonly used. Okay, so what you're going to see in most designs of SANs using fiber channel is what's called the switched mode. So that's going to look like this. So with the switched mode, now notice my 2 switches. So here's switch 1, here's switch 2. These are fiber optic fiber channel switches. So these are specialized switches. And then all these cables that are connected are fiber optic cables that are designed to communicate. The fiber channel SAN has to include the proper connections on the back, the network card. Okay. And each switch has 2 cables, and then each server connects to each of these switches, which is connected to the SAN. Okay, so host 1 connects to switch 1 and switch 2, and then each one of these switches has 2 ports coming into the fiber channel array. All right, so each ESXi host has a minimum of 2 fiber channel HBA ports, and each is physically connected to the 2 switches. So if this cable breaks, we're good to go, right? We can still get from here to the array. If this switch goes down, we're okay because we can still go to this switch to the array. If this cable breaks, both of those break, I can still get there. So a single point of failure is redundantly cabled and connected with the various layouts here. Okay. So that's the fiber channel switch mode, which again, this is the most common system that you'll see. Now the figure shows each ESXi host has a minimum of 2 ports, and each is physically connected to 2 channels, and each switch has 2 connections to 2 redundant front-end array ports across the storage processor, and this is the most common fiber channel configuration. Now all the objects, so on these, we have on our array, this is where our targets are. So we set those up, and it's hard to write with your mouse if you've ever tried to do that. And then these on our servers, we have the initiators. That's an R. Okay, so the initiator has to be able to communicate with the target. That's what all this networking is in between, is to allow that to communicate. But the initiator is on our host server, and then the target is on the host of the SAN. And the initiator communicates with the target. Okay. Now, on a fiber channel SAN, they have a unique 64-bit identifier, which is called a worldwide name. Okay. And these 64 bits ensures that there will be a unique number of fiber channel SAN targets across the globe, right? There's not going to be any of these SANs, they're all going to have a unique worldwide name. So this is like a unique name for each one of them. Now, WWNs can be worldwide port names, which is a port on a switch, or a node name, which is a port on an endpoint. So this is similar to the MAC address on Ethernet. And we know with our MAC addresses, the first 32 bits are the organizational unique identifier, the OUI, and then the last is the manufacturer's name or the unique number. All right. Now, the most significant 2 bytes are used by the vendor, the 4 hexadecimal characters starting on the left, and are unique to the vendor, and then the remaining are there. Okay, so just like Mac, whereas Mac uses half of it is for the OUI, the other half is for the number. The fiber channel uses the first 16 bits, and then the rest of it is 48 bits is for the unique number, because there's not as many manufacturers of SANs, right? So that's fiber channel. That's one of the protocols. A more common protocol today is iSCSI. And iSCSI brings the idea of a block storage SAN to customers that don't have the fiber channel infrastructure. And remember, when we in networking and in PC servicing and our prep classes, CNET60, CNET62, we know one of the downsides to fiber optic cabling is cost, right? So, if you're talking about a small company with a limited budget, they may not have the finances to build everything out using fiber channel, because it is very expensive. iSCSI uses our traditional Ethernet networking, so it can run on our typical Ethernet. Now remember, fiber channel is a proprietary fiber optic network. So it's not the same fiber optic networking we would use with our Ethernet networks. That fiber is compatible with iSCSI, but it's not compatible with fiber channel. It's unique, okay? So what this does is it uses iSCSI, which uses the SCSI protocol, and it does it over the internet. That's what the I is for, is the internet. And it encapsulates. And remember, encapsulation is where we put data inside of another frame, inside of a packet, or a TCP packet inside of the IP packet inside of the frame. So we're putting a box inside of a box, inside of a box, inside of, you know, the delivery mechanism. Okay, so iSCSI will add that data in there, and then it gets unencapsulated on the other side. And iSCSI has the exact same topology as our fiber channel switch network did. So iSCSI, the design is still, this provides us the best type of design for it. The only difference here is that these fiber channel switches now are Ethernet fiber channel or fiber optic. They're not proprietary like they were here. These are proprietary, that this adapter card and this adapter in the back have to be fiber channel, whereas here, these can just be traditional Ethernet connections. So this is just a standard network connection, standard network fiber optic switch, standard Ethernet connection on the back. Okay, so that's the iSCSI. Now, it's very similar to the fiber channel topology. You should use a VLAN or physical isolation to scale up connections. And each host has 2 ports, and each is physically connected to 2 Ethernet fiber switches. And then the VM kernel ports are used by the hypervisor for network traffic. Now, storage and LAN are isolated physically or via the virtual LANs, and each switch has a minimum of 2 connections to 2 front-end array network interfaces on the storage processor. So the same design as before, same terminology. The initiator is the host side device that serves the same function as a physical host bus adapter. And the initiator can be either hardware or software. And then the target is located on the SAN, on the device, the storage device. All right. And then the same kind of terminology as with the fiber channel. And we can secure this with, because it's going over Ethernet, we can use the CHAP, which is the Challenge Handshake Authentication Protocol. And then there's MS-CHAP version 2, version 3, which is more and more secure. Or we can use the IP security, which is the most common. And with the IPsec, it uses the public key encryption techniques, which uses the certificate authorities that are common for most of our other security, that uses the asynchronous security. Okay, or asymmetric, not asynchronous, asymmetric. All right, now here's a typical, the initiator is the host, the target is the drives, and then it tunnels through our Ethernet network to our switches, and then our security will be applied when it's sent, and then it's when it's received. Now I have a link in here that is here. Hold on. Okay, so let me come back into this. So with, I have a link on this, and I just want to go to this real quick. And it basically, I found a website that does a comparison of iSCSI versus fiber channel in the performance. So I'm going to make this a little bit bigger so you can read it a little bit. So, it's the old adage, what's heavier, a pound of bricks or a pound of feathers? Well, they're the same, right? Just you can get a pound of bricks will probably fit in your hand. A pound of feathers might, you might need 2 arms to hold it. It's going to be much bigger. So in storage, an area that is often misunderstood is iSCSI performance and how it compares to fiber channel. Both of these SAN interconnects are typically measured by bandwidth, with 2 gigabit fiber channel SANs dominating the storage market today and 1 gigabit Ethernet used for SANs or iSCSI. Which would you say is faster, a 2 gigabit fiber channel connection or a 1 gigabit Ethernet connection? It's a trick question. They're equally fast. They both transfer data at the speed of light. Bandwidth is not an issue, but size. So this article just goes through, and it's a good read for our iSCSI discussion here. Okay. So I'm going to get through the last protocol, and then we'll take our second break here. But the last one is the oldest one, which is the network file system. And NFS protocol is a standard originally developed by Sun Microsystem that was designed in the Unix world that allowed Unix servers to access remote storage as if it was on the same network, right? So it's the same thing as what we're trying to do with fiber channel and iSCSI. So to enable remote system to access a file system on another host as if it were locally attached. So here's our familiar topology. But again, now these over here are our NFS, network file system storage, data stores that are initiated and targeted using the NFS protocol. Now this, in a lot of ways, this is the easiest one to work with, because once you have NFS set up on your server, wherever that storage device is here, these hosts can easily find it and attach to it. Now, when we get into Hyper-V, which is the second half of the class, so after the midterm, which is in 2 weeks again, we will do a lab in Hyper-V where we will build iSCSI and NFS servers to connect to our host machines, okay? And we're going to do it all virtually. It's not hardware, but it will be done on virtual hardware, and it will give us a good look at NFS. Now, using NFS, data storage moves the elements of storage design associated with the LUNs from the host to the server. Now, not all of these NFS servers are compatible with VMware. So VMware has a hardware compatibility list, which is this HCL, that you can find online. And if you have a NFS server, or if you built an NFS server, you can go out and make sure that it's going to work with your version of VMware ESXi. Okay, so you always want to double check that as well. So we'll wrap this section up by talking about a comparison. So can ESXi boot using fiber channel, using to your fiber channel connection for your SAN? The answer is yes. Can it use iSCSI? The answer is yes, but you have to make sure your hardware and your software initiator supports the boot function in it. Can it boot to an NFS? The answer is no. Can it boot using vSAN? The answer is no. So if you're going to use NFS or vSAN and you want to use that where you're going to boot your ESXi server, you're not going to use a thumb drive, you're not going to use local storage at all. The only two options are fiber channel and iSCSI. Can the virtual machines boot from your data store? The answer should be yes for all of them. Can it do a raw device mapping? The answer is yes for fiber channel and iSCSI, but it's no for the NFS and the SAN, vSAN. Can you dynamically extend your storage? The answer is yes for all of them. And then the availability and the scaling. And then what support VMware features are supported, all of them that we talked about that use shared storage, high availability, vMotion, storage vMotion, and fault tolerance are all available with any of these protocols or storage devices. All right. So as you can see, this gives us a lot to think about when it comes to storage, right? Now, in a lot of ways, this is something that you typically are not thinking about in our labs because I've set everything up, right? Or we're limited to our host machine, our local storage only. And that's fine for this class. That's more than adequate of an understanding. But I always want to make sure we have a deeper dive at some point in our lecture, so you understand that when you go to a enterprise version of this, not a lab learning environment, but an enterprise where they're actually doing this for, you know, their production networks and production environments, that you are at least aware of this, so that when you start working on this stuff and you see how it's cabled, you'll go, I've seen that topology somewhere before. Oh, there's the initiator on the host, there's the target on the drive, and you can make sense of that. All right. Any questions or comments on any of this storage area, network or storage, remote storage that we've talked about this morning? No? Well, if you have a question or a comment, just pop it in there, and I'll do my best to answer it in real time. All right, so I'm going to pause the recording, and let's continue the PowerPoint presentation. And now we're going to switch gears a little bit and get into some of the information on Windows Server in the file and print sharing. Now, we're a little out of sync as far as the lecture material and the lab. Last week's lab, we did a lot of the stuff we're going to talk about today, but that's okay. Sometimes, you know, you want to do the lab and then lecture. Sometimes you want to lecture and do the lab. So let's look at file and print services that are built into Server 2019. So the first thing we're going to look at is the protocol. Remember, we talked about the storage protocol for our shared storage. Well, there's also a protocol for our local data sharing as well. So the Windows protocol, the native version, is the server message block, or SMB. And Linux, Linux always is kind of tongue in cheek. You know, it's kind of a cheeky language or cheeky operating system. So their version of SMB, to make it compatible with Windows, is called Samba. So he's put a couple of A's in the SMB. And the protocol that we're going to use today, and the system we're going to use today, is Samba on Linux. So we can easily share the information on a Linux share with our Windows clients, you know, because if we could only communicate Windows with Windows, Linux with Linux, Mac with Mac, if that was the network, the world that we lived in, it would be very difficult to make those distinctions. It's better if everybody can use everything, right? Where there's a lot more compatibility. Now, another version of SMB is the Common Internet File System, or CIFS. Now, the file and print sharing functions are in the file and storage service role. Now, by default, when we installed last week, some of you may have noticed this, when we installed our server, our Active Directory domain services, even before we installed that, our parent server, which we haven't done anything to other than turn it on, sysprep it, and then turned it off, right? That's all we really did with our parent. And then we're using it to clone. It has one of the only services turned on by default is the file and print sharing. So you probably noticed last week when you right clicked on share properties, it was there to start sharing it. It just said not shared, create share, boom, you're done. So it's already installed for us. Now, the Windows also supports NFS, and it has built-in support for iSCSI. So NFS is the native sharing protocol in Unix and Linux, and the server for NFS is a role service found under file and storage services. And as I mentioned, we're going to create a couple of servers to become our storage servers. One of them will be a Windows NFS server. The other one will be a Linux iSCSI server. Okay, now Windows shares printers using the SMB protocol, but also supports other protocols for printers, the LPR, the LPD, and the Internet Printing Protocol. Now, there's two ways to secure our files. One is we can go into the share permissions. So when we share, we can say read, read, write, and that's basically it. And then the other one we can do is with the NTFS, which is our new technology file system permissions. And our permissions are how we determine who is authorized or authorized to do various things. So it specifies which user can access a file and what users can do with that object. Now, share permissions only apply to a network share. NTFS permissions are applied to both local and network shares. So by using both of them, we can have a very granular or detailed approach to what we want to share. Now, there are three types of security objects, which are called security principals. And they can be used to assign permissions. We can either assign permissions to the users, we can assign permissions to the groups, or we can assign the permission to the computer that connects to the server. Okay. Now, the security settings have three components that makes up the security descriptor: the discretionary access control list, the object owner, and then the system access control list. All right. So the DACL is a list of security principles. Each has permissions that define access to an object. The ACE, which is the access control entry, is an entry in the discretionary access control list. And then the owner is normally the creator. So whoever created the object, so like when we install Windows, the system is the owner. When we're logged in as the administrator and we create a file share, the administrator is the owner. If we were to log in as user one on our domain and create a share, user one would be the owner. Okay. And then the system access control list is a file system component that defines the settings for auditing. So the SACL is used with the audit feature. All right. Now, users can be assigned permissions in four ways. One, if they create the object, they're the owner. If the user account is added to the discretionary access control list, and that's known as explicit permission, or if the group the user belongs to is added to the DACL, that's also considered explicit permission, or if the permission is inherited from the DACL of a parent object to the object underneath it. And that's known as inherited permission. So the principle of inheritance is if I create permissions on a folder, anything inside of that folder will have the same permissions as the original parent folder. So if I create another folder inside of that original folder, and I create a file inside of that second folder, and then another file, all of that is going to inherit from the parent. Okay, so those are how the permissions are assigned, or how they make their way down to the user. Now with share permissions, we again, these only apply to something accessed across the network. And share permissions cannot be assigned to an individual file. They're only assignable to folders. And the three permissions are read, change, or full control. Now, by default, everyone has permissions to read. So, and all users, all system users, when we create a user, they are part of the everyone group. One of the first things I always do when I do a file share is remove the everyone permission. Just go in there and get rid of it. Okay, that way I'm in control. I know who is going to have access. Because if you don't, and you have something in there, even though it's a read only, they can still read it and, you know, make a copy of it or take a screenshot of it or a picture of it on their phone. And then, you know, you may have some security problems. Okay, so those are share permissions. That's what we did last week. We did the share permissions. This week, we're going to do a little bit like NTFS permissions, but we're going to use the user permission with the group owner and other permissions. So NTFS permissions can be configured on folders and files. Folders, there's 6 permissions that we can modify, and 14 special permissions. So remember I said it's more granular? That's 20 different things we can do on a folder. Files, we have 5 permissions and 13 special permissions. So there's 18 different file permissions that we can set. Whereas with our share, there's only folder permissions. There are no file permissions. Okay. NTFS, the standard permissions are read and execute, list folder contents, write, modify, full. So here's a detailed list of the special permissions. So you can read through these and, you know, for your completeness. Now, file and folder ownership, whoever creates the file is the owner. So a user can become the owner 3 different ways. One, they create it, or they can take ownership, but they have to have the permissions. You cannot take ownership from the administrator unless you're an administrator. So you can take the ownership, or the administrator can assign you as an owner. So you can become an additional owner for a file. Okay. Any questions on any of these permissions? I know I'm going through them really quick. This is stuff we've covered in other courses. So if this is your first time, just make sure you come back and really digest this. All right. The inheritance. Now remember, inheritance, whatever we set on the parent folder is inherited by everything inside of it. So by default, initial permissions are set at the root of a volume. So if you go to the root of your C drive on your server, it will have a certain set of permissions that will go to everything underneath it. That way you don't have to set the permissions on everything underneath every subfolder and file. That would be really kind of convoluted way of managing the system. Now, subfolders and files are configured to inherit permissions by default. However, we can break inheritance. We can tell a folder, do not inherit from the parent above you. That's a setting we can go into. So disable it, you go in the advanced security settings and disable the inheritance system. So here's where this is showing the advanced, and we can click on whatever user we want and then hit disable inheritance. And that will stop the inheritance from occurring. Now, the effective access. Effective access is the access a security principal has to a file system object when taking sharing permissions, NTFS permissions, and group membership into account. So the advanced security setting dialog box has an effective access tab. So if you're not sure how the user is set up, go into this advanced security setting. This is a folder called test perm that's shared, and click on the effective access, and it will tell you which user or group. So this is the sales one user on the 410 server server, and it says full control, no. Can he go traverse folders, execute? Yes. List folders? Yes. Read extended values, read permission? Yes, but he can't write, or he can't delete, or he can't take ownership. Okay, so, and all these effective permissions. So you can always see what's going on with that. So if you have a user, if you're ever a system administrator, and someone says, hey, I can do everything I want in this one folder, but in this other folder, I can only do certain things, go and look at the folder and see what the effective permissions are, and see if that user, select that user and see what it is. Maybe their group assignment's wrong. Maybe the permissions aren't set up right, right? Sometimes that stuff can happen. All right, so what happens when we copy or move our files and folders? Do all the permissions go with it, or do they assume the permissions in the folder that we're moving them to? Well, in all things computing, there are some variables that we have to look at. So here are the general rules to keep in mind when you copy or move files or folders either on the same volume. So say we're on my C drive from one folder to another folder, or between volumes. Say I'm going to copy it from the C drive to my X drive. Okay, so a file or folder copied within the same volume or to a different NTFS volume inherits permissions from the destination folder. So if I copy something from one folder to another folder, whatever the permissions are on that destination folder will be inherited by whatever I copy or move over there. A file or folder moved within the same volume. Okay, so if it's copied within, so if it copies it, it inherits the permission. If you move it within the same NTF volume, when you move it, it retains its original permissions. All right, it doesn't inherit. If you copy it, it inherits. If you move it, it keeps its original. Now, a file or folder moved to a different NTFS volume inherits the destination folder. So if I go from my C drive and I move something to my D drive, it will inherit from the D drive. Okay. If I copy it, so this one is, if a file or folder is copied, it inherits. So copy and move will always inherit the destination. All right. Now, a file or folder moved from a FAT or a FAT32 volume to an NTFS volume inherits the destination folder. It will always inherit the NTFS permissions. And the reason for this is that FAT and FAT32 don't support, they don't have any permissions. The permissions really are full permission or no permission. So that's not really permission. Now, if you copy a file from NTFS to FAT32, it loses all its permissions because FAT doesn't support that. Okay, so if you go from FAT to NTFS, it inherits everything. If you move from NTFS to FAT, it loses everything. All right. Any questions on the copying and moving so far? Pretty straightforward once you kind of get a grasp for it. All right. Creating file shares. There's several ways. All things Windows, there's always more than one way to do something. And the simplest way is with the simple file sharing. That's what we did last week. We can also do the advanced sharing. We can go into the shared folder snap-in in computer management. We can go into file and storage services, which is a one of the tools that we can run, and we can also go in the share and storage management. Okay, now, if we use the deny permission, so if we go back to our effective permissions, if we say deny, which these X's are denied, denying should be used cautiously and only for exceptions. As a rule, a deny permission overrides any allowed. Because if I said deny this, but allow this, and they're in competition, deny will always win. The exception is if the deny permission is inherited from a parent object and the allow permission is explicitly added, then the allow permission overrides it. Okay, so only if the deny is inherited can we override it. If they're both inherited, deny will always win. So unless it's inherited, deny is the winner. So if you deny access and allow access, deny wins. If you deny access and then inherit, so you put a folder underneath that original folder and you say allow, then the allow will override the deny. Okay, that's the only exception. Okay, now we can create shares and set a number of sharing options with the new file, our new share wizard in the file and storage service role. And the 5 options are quick, advanced, applications. For the SMB share, those are network shares. And then the NFS share, we can do quick and advanced. All right. Now you can set the following additional options for an SMB share or a network share. Enable access-based enumeration shows only the files and folders to which a user has at least read permission. Allow caching of the share enables or disables offline files known as client-side caching. So we can use some other features like direct access that allows a user to take a copy or have a in their memory of their system, of their operating system, it will show the contents. And then when they double click the file, it will actually go across the network to get it. The original listing is not a network connection to save bandwidth. But if we disable that, then they will only see the files that they can see. We can also encrypt all of our data access. So whenever we retrieve files from the share, the information is encrypted to prevent someone from sniffing it and viewing the contents of the files as they are transferred across the network. All right. Now we can also do all this from the command prompt or from PowerShell. So all these shares, we can create those the same way. We're gonna have a lab later on in the course where we're gonna do all things PowerShell, which is a really fun little lab. There's a game that is in there in PowerShell that you can play that I'll have you create. And you can see that with the net share. Okay, so here's some of the PowerShell commandlets: new SMB share, get SMB share, remove, set, get, and grant. And there are some default shares that are hidden when we first create our system. And we can hide any share by putting a $ after its name. So if we wanted our share to be out there, but not show up in any browser, you know, if they do a network browse or they go / our share's name or server's IP address or name, and it shows up, if they have access, they just double click and they get into it like we did last week. But we want to keep it hidden and then still have it there. We just put a $ at the end of it. Okay, there's a couple of default administrator shares. The admin $ provides network access to the Windows folder on the boot volume. And then the drive $ is created so that the admin always has access to every network share or every network drive. Then the IPC means the interprocess communication. So that's what our services use back and forth. Now, domain controller, which we saw this last week when we went into our share, we saw share and then we saw net logon and sysvol. Those are created that allow our profiles and our Active Directory replication to happen automatically. So those are domain controller specific. Okay, managing shares with the shared folder snap-in. You can use this to create, delete, monitor shares, view open files, monitor who's connected to a share. So like there may be times where, well, I'll get to this in a second, but you may need to restart a server and you're not sure, is anybody in the server? Well, how can you find out? Well, you can go into the shared folder snap-on and say who's connected users. And then if you see, you know, Juan is in there, just call him and say, hey, I need to restart that server that you're connected to. Can you get out of there for, you know, 5 minutes and then whatever. Okay. So it also has the shares, the sessions, and what open files are there. For shared resources to be useful, users have to know how to get to them, right? A lot of times, the best way to do that is to just use mapping a network drive in like a logon script. But, you know, the users will figure out how to get to stuff. And you can get to it by clicking on the network in your computer, right? Click network, it will go out and look and then show you what's available on each share. Or you could double click, you know, whatever you're doing, and it will show you that way. You can also do the UNC path, which is where you would put up here in the address bar, like we did last week, //server. And because our server is on our domain name, because we're using the DNS of our Active Directory, it will show us that no problem. Okay. We can also limit what people can do with our shares. So once they get into the shared folder, what do we want them to do? Now, users are a lot like, have you ever seen like a locust plague where all, like, say there's a field in, you know, Nebraska, a cornfield, and this swarm of locusts come in, and users are a lot like that. If there is space on a file share, they have permissions, they will fill it up faster than you can imagine. And for whatever reason, people like to make sure all their stuff is copied somewhere else. So if you don't limit how much space they can use, they will use it all. Trust me. So we can go into the NTFS volume and right-click properties and get to the quota tab, and we can enable the quota. And there's a couple of ways we can set this. There's a soft quota and a hard quota. A soft quota basically says, hey, you're only allowed 1 terabyte of space. You're now at 995 terabytes. After 5 more gigabytes, 995 gigabytes. After another 5 gigs, you'll be hard quoted. So the hard quota then blocks it, says, and they'll just get a permission error. Sorry, it drives out of space. Sorry, it drives out of space. You do not have permission to write to this drive. Okay. We can enable quota management, but we have to check that box in order for quotas to be enabled. And we can also, let me get to my slide here. We can also deny space to users exceeding the quota limit. So that's known as a hard quota. We cannot limit, so we can make exceptions to the user. Say you have a boss that you want them to have the limit, but they can exceed it, but you still want to audit that to see who's using up all your drive space, or you can limit the disk space to a maximum amount of space users can occupy. Okay. For other options, you can log the events when the user exceeds their quota limit, or log the event when they exceed their warning. So this is their hard quota, this is their soft quota. And quotas can be enabled in a per volume basis and by the file types. So this is part of the disk file management part of Windows Server. So here's the quota where you can say administrators, they have no limit, but this test user, they have 25K, they get a hard limit. The warning is at 10K. So when they get to 10K, they're going to get a warning pop up on their screen. hey, you only have, 15 more K until you cannot use this share anymore, right? Shadow copies is a service that's built into Windows Server, and Windows uses this so that if we have a share and we enable shadow copies, it allows a user on that share to right click on the share and go back to a previous version. This is a godsend for help desk employees, because instead of them, let's say I'm the user and I'm working on a file and I delete it for whatever reason, user error. I call the help desk and say, hey, I was just in this file and I deleted it. Can you restore that from a backup? Well, they're going to have to go in there, but what they can do really easily is go to the backup, right click, restore, done. Now, let's say I'm a user and I'm working on, say, today's PowerPoint, and I'm working on today's PowerPoint and I save it, but I meant to save as. So now this week's PowerPoint, I'm working on next week. But I saved this week's, now I lost this week's PowerPoint, right? I overwrote it. Well, I can go into my share onto that file, right click properties, previous versions, and I can select the previous version, of yesterday and restore that. And now I have that version. And once users learn how to do that, it's going to eliminate all those phone calls to the help desk. So they can just go in, oops, right click, previous version, and away they go. So volumes used heavily for sharing files should be configured to use a different volume for storing the shadow copies. That way we can get a copy of both of them, right? So here's the settings, and we can tell it the storage area and then the maximum size limit, where we can set the quotas there and the shadow copies. All right. And then there's some information about the shadow copies. It will only do, assuming you have enough hard drive space, up to 64. If you have more than 64 versions, it will start deleting the oldest version. Okay, work folders. We can create work folders that will automatically synchronize from their workstation to the server as soon as their workstation has access to the server. So this is great for people that work with their data on the server, but they want to take their laptop or their computing device home, and they can, before they leave, all those folders on their work computer will be updated and synchronized with the server. And then when they go offline, they can work on it. And then as soon as they come back, it will automatically synchronize and encrypt it to the server. And this is great for remote workers, but it does have to be turned on and set up, right? But it doesn't work collaboratively. So if someone else changes that file on the server and you bring in your laptop and it synchronizes, your version will overwrite that. So you want to be careful with that. If you need collaboration, then there's really great cloud services that probably work better than that. Dropbox, OneDrive, Google Drive, all those work really good. All right. Here's installing, printing, real similar to the files. When whoever creates the printer is the owner, everybody else you can give permissions. Here's the some of the permissions you can give there. The pooling, printer priority. You can assign a higher priority to certain users. So if there's a big list of people waiting to use the printer, but the boss needs to print something, they may have a higher priority, so theirs will jump the line and be able to print first. Okay, here's configuring a print. It's exactly the same way as doing the folders, and you just right click on it, sharing, and share it from there. Here's some advanced printing sharing, similar to the advanced file sharing. And here's the advanced. You can come in and set it up there. You can share the printer with other drivers, right? So if you have users that are not on, let's say, a 64-bit operating system, you can share the 32-bit version of the print driver as well. You have to install it or upload it, and then it'll take it from there. There is no permission inheritance for printers because you can't put a printer inside of a printer, right? There's standalone devices, so there really isn't anything inherent. There's the standard permissions, which is print, manage, and manage documents. And then there's special permissions, pause, resume, restart, cancel, and properties. And one of the things you want to be careful of on a server is that you install the printer as the user who's going to own, who you really want to take care of the printer, because you might not want to get a call every time somebody in the financial aid office has a problem with their printer, right? Install it as that user. So if John is the main person using the financial aid printer, install it as that user. That way they have full permissions. And then they're not going to call you. Why can't I do this? Or why can't I change this? Just let them take ownership of it and away they go. Or you can assign ownership. All right. You can do PowerShell print. Some of the print queue problems. How many of you have ever had a printer that says there's an error communicating with the printer, you restart your computer and you still get that error? Well, sometimes what you have to do is go in and stop the print spooler and then restart it, which you can do either from the PowerShell or with the net command as shown here. Remote desktop printing. So this uses the Easy Printer driver to allow local printing during an RDP session. So when a client connects to a computer via remote desktop and they want to print, they'll see a list of available printers as if they're on their remote network. So it's kind of like a VPN print service. All right. And I believe we're almost to the end here. And there's some more printing stuff. You can read this on your own time. You can also set up the branch office direct printing, which allows clients to print directly to a network attached printer without the job having to go through the print server. So you have to enable this and set that up. This is similar to the direct access and the VPN stuff. This is kind of in that category of services. And that gets us to the end of today's lecture. So we talked about all of the storage features from an ESXi standpoint. We looked at some of the characteristics of our disk subsystems. We talked about their their speed, their latency, the input output per second. Then we talked about hard drives, the physical hard drive characteristics, right? The RPM, and then the connectivity, whether it's SATA, serial attached SCSI, solid state. And then we looked at the network protocols that are used for our SANs with the fiber channel, the iSCSI, and the NFS. And then finally, we looked at how to set all those up within our ESXi with the topologies and talked about initiators and targets. And then finally, we talked about file and print sharing in Windows Server 2019, defined all of the permissions, whether it's a share permission or an NTFS permission. We talked about how those move, how to set those up. And finally, we looked at quotas and printers, right? A lot of stuff to look at today. A lot of these features that we did we actually did these in last week's lab. So let me, I'm going to just transition right into the lab. If you have need to take a break, go ahead and feel free to take a break. Everything for this week is already published, so you should have been able to since late last night actually gotten into this lab folder. So let me just pull open what you're going to do. So here's and again, we're going to use CentOS as our server. So last week you used Windows file, the Windows Server dash DC as our share. This week we're going to use CentOS. So I don't know why that's taking forever, but let's go back into it. There it goes. So again, you're going to connect to your Apache Guacamole. You should know how to do that, I hope, by now. And then connect to your machine, connect to your ESXi server, and then you're going to clone CentOS 8-parent. So we've done this now multiple times. You should be comfortable making a clone. Make sure you clone the CentOS 8-parent. So go into your data store, create a new folder, CentOS 8-Samba, and then go to CentOS 8-parent and copy the CentOS 8-parent-VMX file to the CentOS 8 Samba folder, and then do the same thing with the VMDK file. When that's done copying, right-click on the VMX, register, and then go into it, rename it. And so the same thing we've done, make sure that the network is set to VM network, which it should be. By default, we're using the school's network today, okay? And then it should only have one network card. And then once it's installed, from the CentOS 8 Samba install web admin services all the way until our test connectivity, all of that is located in this video. So if you go to the modules week 6, the week 6 video, I have a link here, and this video will show you me doing today's lab. So, hi, welcome to week 6 of CNET58. I wanted to make a short video and walk you through this week's lab. So let me share my screen. All right, so that's the video that you'll be able to reference while you're doing today's lab. Today's lab is not terribly long, okay? So if there's any questions, I'm gonna be on Zoom the whole time. So until 2:40, I'll be on Zoom unless everybody finishes, then I'll get off. But feel free to work with your systems. Now we're not making any changes to our Windows 10 machine. The only thing we need to do is make sure it's on the right network, which I talk about that in the video and in the lab. And then to test connectivity, all you're going to do is go to that share, make a folder, make a file inside the folder, and then take a screenshot that shows that. And I want to see your server name or server IP address. That way I know it's your server, not someone else's. Okay. And then just submit that and I'll grade those and you'll probably get 10 point or 20 out of 20 on the lab. Any questions on what we're doing today? It is CentOS. So make sure that you, if you type a command and you get an error, check the syntax. Make sure you have everything spelled right. You have the spacing right. I try to take screenshots so it shows the wrong password. Let me check that out, Ian. Anybody else having a problem with the password? So week 6 videos. Let me switch to student view.
I think it's good for me. I think maybe if you copy and paste it, you accidentally got like a space.
Oh yeah, if you copy the password, you got to make sure you only get the little chunk of it. But let me copy that. Yeah, mine just goes in because I'm logged in as Zoom as me, so I'm not going to be able to test that. But yeah, make sure no spaces. That's good advice. So okay, so if you have any questions, you can probably the easiest way I can see your questions. If you go into at the bottom of your screen where you have share screen and chat and all that, if you go into reactions and then just raise hand. If you click on raise hand, you'll automatically, you'll go to the top of my participant list and I'll be able to see that you have a question. You can also just pop it into the chat and I'll see that. Or if you see me on the video, just start talking to me or, you know, whatever, and I'll notice you, because I do walk back and forth between my office and the kitchen every now and then. You know, I'll eat lunch at around 12 and all that. So I'll be in and out, but I'll be available. I'm available to you. All right. So there's that. All right. Good luck. I'm going to stop the recording.